So my name is Carl Eklund. I'm an architect at Red Hat. And today I'd like to share with you a new product that we have specifically for data scientists. It's called Red Hat OpenShift Data Science. It's a fully featured data science environment sitting on top of OpenShift as a managed cloud service. Our goal with this product is to give data scientists the ability to produce production-ready models as quickly as possible, all from just the one platform. So I'm going to give a quick overview of the product itself and then cut to a demo that I prepared in advance that highlights how Red Hat OpenShift Data Science and Starburst can work together to achieve results in rapid time, rapid succession, get you as many models as you need, and push them all to production. So if we have time, I'll leave it for questions posted in the chat. So I always like to begin these conversations by highlighting the enterprise data landscape at a high level. I know you guys have spent a lot of time discussing this today, so we'll go through this a little quickly. We all know that actual data flows in an enterprise environment are a lot more complicated than what I've depicted here. But what we tried to do is just simplify the categories, or I like to call them building blocks because it reminds me of Legos. But the point is that it aligns loosely to three main sections, or columns if you really look at this diagram. On the left-hand side, you have your operations, your data sources, your data engineering. The center column depicts artificial intelligence and machine learning workflows. And the right-hand side of this shows traditional business intelligence where curated data sets can be consumed out of a warehouse, consumed by reports and dashboards, and ultimately human consumers, mostly manually. So this second generation architectural pattern, it's still pretty common, but increasingly we are seeing the shift to decentralized data mesh paradigms. This allows data scientists, as you all know, to self-serve data products that are applicable to your product or your project directly. Red Hat OpenShift Data Science, which I highlighted the space that we have optimized ourselves in here in red, doesn't care where you keep your data. It could be the data lake, it could be a specific domain. Instead, we are the computational center of your artificial intelligence and machine learning workflow. So if we work our way up this stack, a data scientist can ingest the data from a data lake or the domain into the Red Hat OpenShift Data Science platform, explore it, build their model, deploy their model, and of course, monitor for performance. So that workflow that I just highlighted, something we're all familiar with, it's the machine learning lifecycle, and it's what we specifically designed Red Hat OpenShift Data Science around. So our motivation really is to make sure that data scientists can focus on the top layer, that machine learning lifecycle. We don't want data scientists to have to focus on the underlying infrastructure or become OpenShift experts, just to get work done. Instead, we want to provide them with the tools and capabilities necessary for them to be productive. Data scientists should be testing their hypotheses, exploring their data, using their preferred libraries, and they can do all of that from within a Jupyter notebook. They can leverage GPUs if their workflow can benefit from it, of course. And then when models are ready, push those models to production. You can do that either using source to image, which is a great project, or RESTful APIs to start with. Your enterprise can receive all of those benefits without being locked into a particular vendor. So Red Hat, we're open source leaders. We lean into community projects. We lean into our partner solutions and our partner ecosystems. So when you stand up a cloud environment with us, you're free to leverage your own tools. You're free to leverage Red Hat tools in our portfolio, our consulting services, et cetera. But you're also encouraged to bring partner solutions, and we've made many of them available through the Red Hat marketplace. So to get started using the platform, I'm going to cut to a quick video, and we will demonstrate where Starburst fits in this diagram. We will consume data using Starburst into our environment and start exploring it. In this video, we will demonstrate how a data scientist can gain access to multiple data sets quickly using Starburst data offerings, and explore that data in their Red Hat OpenShift data science environment. The data scientist will have direct access to chatbot messages on a Kafka queue, customer information, and transaction data. Their goal is to enhance the chatbot's functionality using natural language processing. But before they can get started modeling, they need access and an understanding of the data they'll be using. Let's get started. Here are the resources they'll be using today: a Kafka queue, data lake, customer domain database, financial information, and Starburst Enterprise. To get started, they open a Red Hat OpenShift data science environment by going to the grid at the top right corner. Once in the environment, the data scientist can select the services they would like to use. Jupyter Hub is the most common. Future versions of this product will contain multiple open source projects and partner offerings like Starburst Data. The first option is to select a notebook image. There are a number of images to choose from. Standard data science has almost everything we would be using today. Other options include TensorFlow for GPU accelerated notebooks, or a minimal Python image for straightforward exploratory data analysis. Here, the data scientist can select the appropriate node size for the work they will be doing. Lastly, any environment variables we would like to use within the platform, but not stored in our Git repository, we can enter here. Once complete, we will start our server. On the left-hand side, we can open and clone a Git repository and paste to clone. Now on the left-hand side, in the file browser, you can see our project. By clicking into it, you'll see our notebooks, license, a very simple README, and requirements.txt file. Now I will open all of the notebooks we have prepared today. Notebook number 1 is a Kafka consumer. It consumes messages from our chatbot. It's a very simple application. First, we import the environment variables we didn't want stored in Git. Next, we connect to a Kafka topic. And simply wait for those messages to be displayed. Our Kafka producer is the chatbot application itself. As you can see in this code here, it's very simple. In fact, it's just a call and response. Let's run that and type some sample messages. We can see everything is hooked up correctly. Our consumer is in fact receiving messages through the chatbot application. Now let's move on to exploring the data. We of course could install additional requirements if necessary. We need to import them and grab the environment variables we need to connect to Starburst. We can make a simple connection and display the catalogs that are already available to us. We have our customer domain, a data lake, finance domain, and the Kafka queue. Here we ran a simple query on our Kafka queue. We cleaned that data and are displaying the first few entries. As you can see, the TXT column contains messages sent through our chatbot. We can do the same thing for our customer domain. And gather and clean transaction information. Do a quick sanity check. Make sure we're pulling the data we think we're pulling. And investigate both data frames. Next, we can do a simple join between our customer and financial databases. However, these types of queries could also be pushed through Starburst to the databases themselves. We can then look for patterns in the data. Unfortunately, this scatter plot of customer spend by market segment isn't very informative. From here, our data scientist can open a new notebook, install natural language processing toolkits, and explore chatbot messages. When complete, our data scientist can use Git to start tracking their new notebook and commit any changes they would like to record. I hope this gives you an idea of how a data scientist can use the Red Hat OpenShift data science platform and Starburst to get quick access to the data they need, explore it, and start building models. Thanks. All right. Red Hat OpenShift Data Science is a managed cloud service that sits on top of OpenShift. It combines Red Hat technologies with key partner solutions, so data scientists have everything they need to be successful in consuming data, building models, and then deploying and monitoring them. And the whole point of this would be to create as many models as possible, evaluate them against each other, and really get a return on your investment. So thank you very much.